section and test on it. So we'll probably test on Wednesday, or no, probably Thursday. I'll let you know tomorrow. But what we're going to do the next couple of days is review. The test won't have many questions on it. It might have like 5 or 3, because they're going to be these questions that are longer. All right. So like when you look at tonight's assignment or today's assignment, it's only, I think there's 2 questions on it. Okay. So the handout that I gave you today takes you through how to do this question on Math Excel. All right. So Math Excel, you'll see a real similar question to this. And this was just meant to kind of help you understand how to work through it. Okay. So you got 2 questions on your assignment, one having to do with tides and the other one having to do with the number of daylight hours, where you have to come up with a model and then use that model to make some predictions. Okay. All right. So for example, here's what the first question is going to look like on your Math Excel. Okay. So you're given the length of time between 2 high tides is 12 hours and 27 minutes. So right now, guys, you know that that's your period. Okay, now what we're going to do is convert that into a decimal. So this is where you'll need your calculator. Okay. All right, so right here, this is going to be your period because it's the time between 2 maxes. All right, so here's our period. Okay, now to turn that into a decimal, okay, 12 hours, 27 minutes. So what I'm going to do to write it as a decimal, 12 hours, 27 minutes is going to equal 12 plus 27 divided by 60. And that's going to convert it into a decimal. Okay, so on your calculators, you're going to go 12 plus 27 over 60. Clear this guy. 12 plus 27 minutes divided by 60 minutes. Okay, and that's the period as a decimal. Okay, so this would be the same as 12.45 hours. So it's not 12.27. That's a mistake. All right, so the first question's pretty straightforward. It says, when's the next high tide going to occur? Okay, well, the first high tide was at 12:27 a.m. It was high tide. So we're going to add to that another 12 hours and 27 minutes. Because that's the period. And then write out what that time would be. So if we had 12:27, then this is 12:27 a.m. and we add 12 hours and 27 minutes to it, Well, if you add 12 hours, you're going to be at 12:27. And now I'm going to add 27 more minutes. So this would end up at 12:54. Okay, so 12 hours later, it's going to put me at 12, this is 12:27, then I'm going to end up at 12:54. This is 12:27 in the night, midnight, after midnight, and this is now going to be 12:54 p.m., early afternoon. Okay. Any questions on how I'm getting that? 12 plus 12, and then 27 plus 27. So that's pretty straightforward. All right, now, so on a particular day, we know that high tide's at 12:27. Okay. So right after it, it says 0.45 hours. This just means 0.45 hours after midnight. And then low tide occurred at 7:08, which if you converted that into a decimal would be 7.13 hours after midnight. Okay, water heights are measured as the amounts above or below the average low water. The height of the water at high tide is 596. So we know that this is our max. And the height of the water at low tide is 0.07. So we know that's our min. And it says complete parts A through C. Well, we already did A. So this would equal 12:54 p.m. All right, now we got to come up with the function. Okay, now the way that Math Excel writes the function is different than the way we do. They just use different letters. Okay, we're used to we use an A, but we've been using a B right here. Then we've been using a C right there, and we've been using a D. They're just using, this is the Greek letter omega. And this is the Greek letter phi. Those are just taking place, they're just using different symbols, guys. They mean the same thing. This is still the frequency. This is your phase shift. Times the frequency. And this is still the frequency, just like it was over here. Okay. All right. So we know how to do the first two parts, getting the amplitude and the midline, the vertical shift, is just using the max and the min, right? So we know our max, 596, our min, and divide that by 2. And round that to 2 decimal places. Okay, so that's pretty easy. 6 minus 0, 7 divided by 2. And then I'm going to add them to get the midline, so I'll do that while I'm up here. 6 plus 0.07 divided by 2. So there's our values. This guy is going to be 589. Divide it by 2. Get 2.945. I round that to the nearest hundredth, 0.295. Okay, so that's my A value. Okay, now you add them and you divide by 2 to get your midline or your vertical shift. So in this problem, that is the big B. That's capital B. It's our midline or vertical shift. Okay, all right, so it's plus 3.015, and when I round that, 3.02. So we got our value of A, got our value of what this formula calls capital B. Okay, and now we got to do the frequency. So our frequency is, in this format, is called omega. Okay, we used to call it B. Okay, so this is your frequency. Okay, now the way that we did this was we took the formula that we usually used was the period is 2 pi divided by, when we first did it in here, since we used the letter little b, it was that. Okay, and then we learned that we could, if we solve this for b, it equaled this. Well, you're doing the exact same thing here, except instead of a b, it's using Greek letter omega. That's all. So if I take this formula right here and I rearrange it, it's the same as that. Okay? Any questions up to this point, folks? All right, so we're going to use omega equals 2 pi divided by our period. Okay, so that's going to be 2 pi divided by 12.45 hours. So that's why we converted the period from hours and minutes to decimals. You're not using 12 hours, 27 minutes. You're using 12.45 hours. Okay, so you got to convert hours into a decimal, hours, minutes to a decimal. And we're going to round this to the nearest thousandth. Okay, so we'll do that on our calculator. Okay, and that's going to be 2 pi 2 pi divided by 12.45. I'm going to go out to 3 decimal places on this one. This is 5, 0, 4, 6, 5, 0. And that's your frequency. It's pretty close to a half. All right, so far here's what our model looks like. A equals, or Y equals, let's see, A was 2.95 sine, okay, omega was 0.505 minus B plus B, which was 302. Okay, now we got to, all we need now is this. Okay, so remember, this is equal to the phase shift times the frequency. It's like the phase shift's disguised in it. This. When it's written in this form, C is the phase shift. When it's written in this form, the phase shift is actually disguised. It's the frequency times the phase shift, or excuse me, the frequency, times the phase shift. Okay, so it's kind of disguised. All right, so that's something you got to keep in mind as we're doing this. All right, back to where we were. Okay. So we got to figure out our phase shift. So here's how we did it on all the other ones. We took the period and we divided it by 4. Okay, giving the time belonging to the theoretical first max. So if you look what I did, I took our period, okay, I divided it by 4, and then I rounded this to the nearest thousandths. Okay, so this is how many hours after midnight that the max would occur, our theoretical max. So you notice that our theoretical max would occur around 3 in the morning. Okay, but over here, the actual graph, okay, the theoretical max occurs 0.45 hours after midnight. This is, let's see, what's our max? Max is 596. So this point, 596. And our theoretical point is 5, 6. Okay. So what we have to do is, how far do we got to take this point over here and move it so that it lines up with this point? Well, which way would you have to move it? This is at 3, this is at 0.45. Would you move this to the right or to the left? Think, where's 0.45 if this was 3? Yeah, 0.545 is going to be way over here somewhere. So you're going to have to shift this to the left so that it lines up with that. And so to figure out how far you shift it, okay, you take the actual max, okay, this is from our data. This is the time from our theoretical. And you subtract them. So we have to, this would be, we're going to subtract 0.663. 0.45, that's when the max occurred. So when the first max occurred at 12:27 a.m., which is 12.45 hours, or it's really 0, because we're counting from midnight. So in the data that we're given, this number is when the actual high tide was. Based on the theory, it should be around 3 in the morning, but it's not. So we got to shift it so that we want to shift this to this point. And the way we got to shift it is we're going to slide it 0.263 units left. Okay, now remember when you want to slide something left? Okay, well, let's just put it in like this. This is going to be, which A was 0.295. So this would be 0.295 sine, okay, 0.505. And now I'm going to put in the phase shift. Okay, so remember, if I wanted to move something to the left, the way that I wrote it, see how it says x minus the phase shift? So this would be x minus negative 2.663. Well, that's the same as x plus 0.6. Remember Bizarro World? This actually meant slide left. That's really 2.663 left. Yep. So all you gotta do is drop that right here. X plus 0.663. So what you did here was you replaced, there used to be an x there, but now you replaced it with x plus 0.6. Okay, so to get it to look like this is what Math Excel wants it like. So all you do is distribute. So I'm going to multiply those two, and I'm going to multiply those two. And that's going to give me my final equation. So that's why you only have a couple of these, because they take a while. So this is going to be 0.295 sine 0.505x plus, and now I'm going to multiply 0.505 times 2.66. That on the calculator. 505 times 2. And I'm going to round that to 3 decimal places. 1.3448, 1.345. And there's your equation. So the hardest part on this is really doing the phase shift. So the first part of this problem is just writing out that formula. Okay, so when you do this on Math Excel, you're just going to fill in these boxes right here. Okay, in our case, our first high tide was at 12:54 a.m. So I would type 12:54, p.m. And then our formula is 2.95 0.505x 0.1345 and 3.02. Okay, now the last part, you're going to use this to make a prediction. Okay, the question is, when is the water, what's the height of the water at 6 p.m.? Okay, well, when I did it, I made it 7 p.m. So we'll just leave it as 7 p.m. Okay, so at 7 o'clock, we want to know how high the water is. So what you have to do is you've got to figure out how much time was there between 12:27 a.m. and 7 p.m. Okay, so find out the elapsed time. How much time between these two amounts? How long? 16 hours and 33 minutes. Okay. Anyone else? Well, 33 minutes is going to take you to 1 p.m. Or, I'm sorry, 1 a.m. I'm sorry, 1 a.m. Okay, now how many hours between 1 a.m. and 7 p.m.? One a.m. So there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now it's 12 noon. 12, 13, 14, 15, 16, 17, 18. So 18 hours. So this is going to be 18 hours, 0 minutes from 1 a.m. to 7 p.m. Okay, so grand total 18 hours, 33 minutes. Now, convert that to a decimal. That's 18 hours plus 33 over 60. Okay, so we do that. Okay, 18 plus 33 divided by 60. 18.55. Okay, now what we're going to do is just plug that in for x in our equation. And we're going to do that on our calculator. Okay, so first thing you got to do, guys, is you got to, when you're using your calculator, since we used 2 pi, you press mode and you make sure that here, see, mine says degree. I want to highlight radians and hit enter. So if you're not in radians, you'll get the wrong answer. So that's just mode and then highlight radians and hit enter. If it's already highlighted, you're okay. And then I'm just going to go second quit. So now we're in the right mode. This is critical here. All right, and now here it goes. Y equals, and all we're going to do is put this number in for x. So 2.95 sine 0.505, and now I'm going to put in for x 18.5. And then the rest of it is the same. Plus 3.45 plus 3.0 or 3.02. Now, you just type that into your calculator exactly how you read it. that, second quit, that. Okay, and now we're going to type it all in. Plus, close the parentheses, and there's your answer. 0.187 2, and if we round that to the nearest thousands, it's going to be 1.87, and this is all getting measured in feet. So this is the depth of the water at 7 p.m. And there you have it, guys. Okay. Questions on where any of these numbers came from? I did something you're not quite sure of. All right, so now what you're going to do is you're going to open up your Math Excel and you're going to try the first problem, which is just like this. So use this as like a guide.